Welcome to Marine Gurukul video series. We are happy to present this video on Rendezvous, which besides helping you in solving the questions in your examination, may also be very useful to you on board in a real life situation when you are required to meet up with another ship. In this video, we will be understanding what rendezvous means. What are the different scenarios on board where this procedure will be required? How do we carry out the rendezvous plotting and calculation on the chart in all possible conditions? We begin our discussion with the correct pronunciation of the word. It's a kind of tongue twister and correctly pronounced as rendezvous. Moving further to its meaning, which is to meet with another ship, target ship, which may be stopped or moving. The situations on board where rendezvous may be required could be when the ship is proceeding for search and rescue, a search and rescue operation, and the ship needs to meet with the ship in distress, or our ship may be required to meet up with a supply vessel for picking up stores or provisions, or meeting a bunker barge for bunkering. The rendezvous questions can be broadly divided into three scenarios. The simplest one being that there is no current in the area. The second scenario could be the current affecting the own ship as well as the target ship, and the third scenario could be different currents affecting own ship and the target ship. We will now see how rendezvous can be made in all these different possibilities. To benefit the most from this video, it is recommended to be comfortable with the concepts of allowing and counteracting wind and current. In case of any doubts, you may please watch our videos on this topic. We will first see rendezvous without any current. Let's understand this with the help of an example. We can see the question on the screen now. A distressed vessel in position 52 degrees 05 minutes north, 007 degrees 24 minute west is steering 094 degrees true at an engine speed of 11 knots. Own ship in position 51 degrees 51 minutes north, 007 degrees 18 minutes west is to rendezvous the distressed vessel at the earliest. Find the course to steer, the rendezvous position, and the time to rendezvous if own ship maximum engine speed is 12 knots. We can see in this question the position of own ship and target ship is given to us. Target ship course and speed is also known. We need to find the course to steer, the time and position of the rendezvous. Let us first plot the position of own ship and the target ship. You can see own ship position coming up on the screen, represented by A. You can now also see the target ship position represented by B. We will now join these positions with a straight line AB. We now draw the target ship course steered, which is 094 degrees true, and we will mark off 1 hour distance steamed, which is 11 miles. The target speed is given to us in the question as 11 knots. So we mark the point where the target ship course steered 1 hour vector ends, we mark this point as D, delta. Now with our compass centered at point D, delta, where the target ship 1 hour course steered vector ends, we draw an arc with radius equal to our ship engine distance for 1 hour, which in our case is 12 miles. You can see the arc coming up on the screen. This arc is centered at point delta and the radius of the arc is equal to our engine distance for 1 hour, which is 12 miles. This arc cuts the AB line at point E, eco. You can see point eco coming up on the screen. We will now join eco and delta. This line eco delta represents own ship CTS for rendezvous. We can now align our parallel ruler with eco delta line and transfer the CTS obtained to own ship position A. We have the own ship track now in our plot. Let's mark it off with a single arrow. CTS is represented by a single arrow in chart work. The position where it meets the track of the target ship is represented by point C on the screen and a green circle. This point C, Charlie, is the rendezvous position of the ships. AC Alpha Charlie will be the actual track followed by the own ship, and BC Bravo Charlie will be the track followed by the target ship. The course to steer can now be easily read off from the chart using the parallel ruler and the nearest compass rose. The rendezvous position can also be easily read off from the chart. Now to obtain the time of rendezvous, we measure the total distance to be covered by own ship. That is given by Alpha Charlie AC, and we divide this distance AC by our engine speed that is given to us in the question as 12 knots. So time to rendezvous is given to us by AC distance divided by own ship engine speed of 12 knots. The time to rendezvous can also be calculated using the target ship total distance, which is given by BC Bravo Charlie, and dividing it by the target ship engine speed of 11 knots. Whether you calculate the time using the own ship data or the target ship data, both these will give you the same answer. Dividing distance AC Alpha Charlie by own ship speed of 12 knots. In this particular case, we obtain the time to rendezvous as 1 hour and 30 minutes. Now with this, all the required items have been obtained and the solution for this particular question is now complete. I would like to add on a few things just for the sake of conceptual understanding. One, the line AB Alpha Bravo joining the initial position of both the ships is basically the relative line of approach. 2. If you look at the plot closely, you will observe that the question has been solved using the concept of similar triangles. The triangle ABC, Alpha Bravo Charlie, and the triangle EBD, Eco Bravo Delta in our plot are similar triangle. The smaller triangle EBD, Eco Bravo Delta, is for 1 hour duration, and the bigger triangle ABC, Alpha Bravo Charlie, is for the full duration of the rendezvous. So with this, we finish off our first example and the concept of rendezvous without any current. Let us move to our next example. We have the question on the screen now. A distressed vessel in position 52 degrees 05 minutes north, 007 degrees 24 minutes west is steering 094 degrees true at engine speed of 11 knots. Own ship in position 51 degrees 51 minutes north and 007 degrees 18 minutes west is steering a course of 044 degrees true. Find the engine speed to maintain to rendezvous the distressed vessel. Also find the rendezvous position and the time to rendezvous. We can see in this question there is only one difference. In this particular question, own ship course is already given to us, and what is to be calculated is the speed to be maintained, engine speed to be maintained. In the previous example, the speed was given to us and the course was to be found out. So let us first plot the position of own ship and the target ship. You can see own ship position coming up on the screen now, represented by A alpha. You can now also see the target ship position on the screen, represented by B Bravo. We will now join these positions with a straight line AB, Alpha Bravo. We now plot the target ship course steered, which is given to us 094 degrees true, and on this track, the target ship CTS track, we mark off the 1 hour course steered vector. The 1 hour course steered vector is coming up on the screen now as Bravo Delta, BD. BD shows the target ship course steered for 1 hour. The target speed is 11 knots, so the magnitude of this vector is 11 miles. Now from delta, we draw own ship course steered in the reverse direction to meet the line AB at a certain point. You can see our ship course steered of 044 degrees true, which is given in the question. You can see our ship course steered on the screen. Now this course steered meets the line AB at point eco. We have the eco point, E point on the screen. We will now join eco and delta. This line eco delta shows our ship course to steer for rendezvous. We can now measure the length of vector ED, eco delta, from the plot, which gives us the engine speed required to be maintained by own ship for rendezvous. We now transfer the CTS obtained to own ship initial position A. We have the own ship track now in our plot. The position where the own ship track meets the track of the target ship is represented by point Charlie, point C, and a green circle on the screen. This point Charlie, C point, is the rendezvous position of the ships. Vector AC Alpha Charlie will be the actual track followed by the own ship, and vector BC Bravo Charlie will be the track followed by the target ship. The rendezvous position can now be read off from the chart. To obtain the time of rendezvous, we measure the total distance to be covered by own ship, which is given by vector AC Alpha Charlie, and we divide it by our engine speed, that is given by vector ED eco delta, which was calculated earlier. So this completes the second example. Let's move on to our next example. We have the question on the screen now. A distressed vessel in position 52 degrees 05 minutes north, 007 degrees 24 minutes west is steering 094 degrees true at engine speed of 11 knots. Own ship in position 51 degrees 51 minutes north, 007 degrees 18 minutes west is to rendezvous the distressed vessel at the earliest. The current in the area sets 073 degrees true at a rate of 2 knots. Find the course to steer, the rendezvous position, and the time to rendezvous if own ship maximum engine speed is 12 knots. As you can see, the difference in this question from the previous two examples is that there is a certain current in the area. Now to solve this, we will first follow the same procedure as is done without current. So let's plot the own ship position. You can see own ship position coming up on the screen as A alpha, and the target ship position. You can see the target ship position coming on the screen as Bravo, and let's join them. We have the line AB Alpha Bravo joining both the positions. Now we plot the course steered vector of the target ship. We can see the CTS vector of the target ship. The course steered is 094 degrees, and we mark off the 1 hour CTS vector on this track. It is represented by Bravo delta. Now from point delta, we draw an arc of radius equal to the engine distance of own ship for 1 hour. You can see this arc coming up on the screen now. This arc cuts the line AB at point E, eco. We have the eco point on the screen. We now join point eco with delta. We have the eco delta vector on the screen now. Eco delta is the own ship course to steer and engine distance for 1 hour. Now we transfer the own ship CTS to point A. You can see the own ship CTS transferred to our initial position A. This is the own ship CTS visible on the screen now, and this meets the CTS vector of the target ship at point C. We can see point C on the screen. Now, as done in the earlier examples, we will find out the time to cover distance AC by own ship. So we divide the distance AC Alpha Charlie by our engine speed to get the time to cover distance AC using own ship engine speed. And in this case, it comes out to be 1 hour and 30 minutes. Once the time to cover distance AC Alpha Charlie is obtained, we can now apply the current. Now we find the drift of the current for this particular time, which is 1 hour and 30 minutes. With a rate of 2 knots for 1 hour and 30 minutes, the drift comes to 3 miles. We now apply this current vector at point Charlie. You can see the current vector coming up on the screen, marked with 3 arrows, that is the symbol for current. Let's name the endpoint of this current vector as F, Foxtrot. So you see the Foxtrot point coming up on the screen. Charlie Foxtrot CF represents the current vector. Now we join own ship initial position A alpha with the end point of the current vector, that is Foxtrot. So you can see the line joining alpha with Foxtrot. Now please take your attention to the triangle ACF, Alpha Charlie Foxtrot. You will see the triangle ACF, Alpha Charlie Foxtrot, is the course distance and current vector triangle for the own ship for a time period of 1 hour and 30 minutes. The distance AC is covered in 1 hour and 30 minutes. This was calculated earlier. The current vector is also applied for the same time, 1 hour and 30 minutes. And you see the resultant of these two vectors is AF vector, alpha Foxtrot vector, which is the course made good vector of own ship for the same time, that is 1 hour and 30 minutes. So we mark off the course made good vector alpha Foxtrot with the double arrows, and this is the own ship CMG for the same period, 1 hour and 30 minutes. Let's now join the target ship initial position B Bravo with F Foxtrot. You can see the Bravo Foxtrot line coming up on the screen now. Now let's take our attention to triangle BCF, Bravo Charlie Foxtrot. This is the course, distance and current vector triangle for the target ship for a period of 1 hour and 30 minutes. Vector Bravo Charlie is the CTS vector for 1 hour 30 minutes. Vector Charlie Foxtrot is the current vector for 1 hour and 30 minutes. And the resultant of these two, that is Bravo Foxtrot, is the course made good vector of the target ship, again for the same duration of 1 hour and 30 minutes. So we mark it off with double arrows, that is the symbol for course made good. So Bravo Foxtrot is the course made good vector of the target ship. The position where both the course made good vectors meet, that is point Foxtrot in our diagram, is the rendezvous position of the ships. The direction of vector AC Alpha Charlie or the direction of vector ED Eco Delta, both are the same, both are parallel to each other. This gives us the course to steer by own ship to rendezvous with the target ship. We can now read off the CTS using a parallel ruler and the nearest compass rose. The time to rendezvous is obtained as we have done earlier by dividing AC Alpha Charlie which is the total engine distance to be covered by own ship, dividing it by our engine speed of 12 knots as calculated earlier. It is 1 hour and 30 minutes. Now it is very important to note here that when we compare this plot, that is rendezvous with current, with the plotting of rendezvous without current, you can see and appreciate that there is no change in the course to steer. The course to steer by own ship remains the same irrespective of whether current is present in the area or not. Also, you will observe that there is no change in the time to rendezvous. The time to rendezvous is also unaffected by the presence of current in the area. The only change which comes in this scenario when current is present in the area is in the rendezvous position. When we were plotting without current, the rendezvous position came as point Charlie, but when there is current in the area, the rendezvous position comes out to point Foxtrot. So this completes the question. We have calculated all the items which were required from us by the question. Let's move on to the next example now. We have the question on the screen. A distressed vessel in position 52 degrees 05 minutes north, 007 degrees 24 minutes west, experiencing current of 143 degrees true at a rate of 3.5 knots and is steering a course of 077 degrees true at an engine speed of 8.7 knots. Own ship in position 51 degrees 51 minutes north, 007 degrees 18 minutes west is to rendezvous the distressed vessel at the earliest. The current at own ship location is 000 degrees true at a rate of 3.3 knots. Find the course to steer, the rendezvous position, and the time to rendezvous if own ship maximum engine speed is 9 knots. Now, as you can see in this question, we have different currents affecting the target ship and the own ship. So let's see how do we solve this kind of a question. Let's first plot own ship and the target ship position on the chart. You can see own ship position A coming up on the screen, target ship position B Bravo coming up on the screen. We join them as line AB Alpha Bravo. Now at the target ship location, that is point Bravo, we plot 1 hour vector triangle of the target ship. Let's first plot the CTS, which appears on the screen. Let's name the point where the CTS vector ends as C Charlie. Now we apply the target ship current, which is given to us in the question as 143 into 3.5 miles. So you can see the current vector coming up on the screen, 143 degrees, and the drift in 1 hour, which is 3.5 miles. Let's mark the end point of the current vector as D delta. Now if we join point Bravo and delta, that gives us the course made good of the target ship. So you can see the course made good line coming up on the screen now. Let's mark it with double arrows. That is the symbol for CMG. Now from point delta, we draw the current vector affecting the own ship in the reverse direction. The current at own ship location is 000 degrees and the drift in 1 hour is 3.3 miles. So we apply it on point delta, but in the reverse direction. You see the current coming up at point delta. Let's mark the beginning point of the current vector as echo. So you have the echo delta vector on the screen representing the current at own ship location. Now using our compass, we center it at point echo, E point, where the beginning of the current vector is. We draw an arc of radius equal to engine distance of own ship for 1 hour. Our engine speed is 9 knots. So our engine distance in 1 hour, 9 miles. So we place our compass at echo, the radius being 9 miles. We draw an arc so that the arc cuts the line AB, Alpha Bravo. You can see the arc coming up on the screen now. Now let's name this point as Foxtrot, where the arc is cutting line AB. Now we join Foxtrot with echo point. You can see the Foxtrot echo vector showing up on the screen. This Foxtrot echo vector is own ship course to steer and the engine distance to steam for 1 hour. Now joining F Foxtrot with delta D gives us the course to be made good by own ship. You can see the Foxtrot delta vector coming up on the screen. This is the own ship course to be made good. We represent it with double arrows. Now we transfer the own ship course made good to our initial position A, alpha. Once we transfer the course made good vector to our initial position A, we see that this meets the target ship course made good at a certain point. Let's name that point as Golf, G. This point Golf is our rendezvous position. The meeting point of the course made good tracks of both the ships, point Golf, is our rendezvous position. Now for calculating the time to rendezvous, we divide the distance AG, Alpha Golf, that is the total distance to be made good by own ship. So we divide this distance AG, Alpha Golf, by own ship speed made good. Own ship speed made good is obtained by measuring the vector Foxtrot delta, which is our CMG vector for 1 hour. Now, as discussed in earlier examples, the time to rendezvous may also be calculated using the target ship data. How can we do that? That is, if we divide the total distance to be made good by the target ship, in the plot it is Bravo to Golf. Bravo to Golf is the total distance to be made good by the target ship. If we divide it by the target speed made good, the target ship speed made good, which is given by vector Bravo delta, we can obtain the rendezvous time. So whether we obtain the rendezvous time using own ship data or the target ship data, in both the cases the time is going to be the same. Hence we obtain all the required items, that is the course to steer, the rendezvous position, and the time to rendezvous. So I hope you have understood the procedure for making a rendezvous in different scenarios. We have seen it in no current situation. We have seen it in a current situation where a similar current is affecting the own ship as well as the target ship. And now we have seen it in a situation where different currents are affecting the target ship and the own ship. This brings us to the end of this video regarding Rendezvous. I hope you find the video useful, and if so, please do like and share the channel as well as the video, which keeps us motivated. Do subscribe to the channel and write to us in the comment section below. We are also available on marinegurukul@gmail.com. Thank you very much for watching the video. I wish you all the best.